Assalamualaikum and hi Encik Nizam. We are from 2BEZ Section 1. We will present about 80 Mega 328P microcontroller. For the introduction, 80 Mega 328P microcontroller is a single chip microcontroller. It is created by Atmel in the Mega AVR family. It is also a 8-bit microcontroller with 28 pin. This is the 80 Mega 328P diagram pin out. We can see all the pin label at the 80 Mega 328P.
Architecture. It is using AVR enhanced RISC reduced instruction set computer architecture. AVR is a 8-bit RISC architecture microcontroller in market since 1996, which is having on-chip programmable flash memory, SRAM, I/O data space, and EEPROM. AVR is the first MCU in market which has on-chip flash storage. The 80 Mega 328P is a low-power CMOS 8-bit microcontroller. The AVR is also a modified Harvard architecture where program and data are stored in separate physical memory systems that appear in different address spaces but having the ability to read data items from program memory using special instruction. This is the block diagram of AVR architecture. As with any MCU, ALU forms the core of the controller. The ALU of an AVR MCU processes data 8 bits at a time. It performs the arithmetic and logical operations. The data for the ALU comes from the registers.
This 8 Mega 328P is 8-bit microcontroller. It is non-programmable data and program memory. It also high performance. Next, it is lower power consumption. It also on-chip analog comparator. It supports X1 RISC architecture with 131 powerful instructions. It supports 32 KB flash program memory. It supports 2 KB internal SRAM. S stands for static RAM. It also supports 1 KB EEPROM and it is 28 pin.
Interrupts feature. It have 25 different interrupts source. The interrupts and the separate reset vector each have a separate program vector located at lowest addresses in the flash program memory space. This is the complete list of vectors in 80 Mega 328P. As you can see, each interrupt vector occupies 2 instruction words. The list also determines the priority levels of the different interrupts. The lower the address, the higher is the priority level. Reset has the highest priority and next is into the internal interrupt request 0. 80 Mega 328P interrupt processing. This is the figure of status register. When an interrupt occurs, the microcontroller completes the current instruction and it stores the address of the next instruction on the stack. It also turns off the interrupt system to prevent further interrupts while one is in progress. This is done by clearing the SREG global interrupt enable I bit. The interrupt flag bit is cleared for type 1 interrupts only. The execution of the ISR is performed by loading the beginning address of the ISR specific for that interrupt into the program counter. The AVR processor starts running the ISR. The execution of the ISR continues until the return from interrupt instruction RETI is encountered. The SR EGI bit is automatically set when the RETI instruction is executed. When the AVR exits from an interrupt, it will always return to the interrupted program and execute one more instruction before any pending interrupt is served.
There is 3 timers in microcontroller. There is timer 0, timer 1 and timer 2. In timer 0 has 8-bit timer. Counter can register maximum value until 255 and the output at OCOA and OCOB. In timer 1 has 16-bit PWM and maximum value counter until 65,535 and the output at OC1A and OC1B. And for timer 2 has 8-bit PWM similar to timer 1 and the output at OC2A and OC3B. This is the timer and counter control register. There is 8 bits from 0 until 7 and the initial value is 0.
Next, I will explain about PWM. From the 14 in I/O port, 6 pin can be used for PWM output. And from the 6 PWM output, 2 are located on each timer and counter. This PWM is capable of running in 3 different modes. There is fast PWM, phase corrected PWM, phase and frequency phase corrected PWM. For fast PWM, it works the same way as the normal counter, where it used for DAC, fading LEDs, rectification and power regulation. For phase corrected PWM, it will count until it hits the top value and then start to count down until it hits the bottom value. This is recommended for motor control. For phase frequency phase corrected PWM, it has the same way function as the phase corrected PWM. Also recommended to use for motor control only. Next, ADC. The ADC for this microcontroller 80MHz 328P, it is capable for converting an analog voltage into a 10-bit number from 0 to 1023 or an 8-bit number from 0 to 255. This 10-bit resolution ADC 8-channel analog multiplexer, which allow 8 single-ended voltage input construct from the pin from port A. This single-ended voltage input refer to the ground.
Next, I will continue on input-output peripheral. There are 6 analog input pins. 14 input-output digital ports allow the external connection with any circuit with the microcontroller. For output, if 1 is written as configured at output pin, it will drive the port pin high. If 0 is written as configured at output pin, it will drive the port pin low. And for input, if 1 is written as configured at input pin, the pull-up resistor is activated. And if 0 is written as configured at input pin, the port is in tri-state, which is leaving the pin left floating. Okay, this is a digital input-output pin. Okay, there are 3 ports, which is port B, port C, and port D. For port B, the pin are pin 9, pin 10, pin 14, pin 15 until pin 19. For port C, the pin is pin 23 until pin 28. For port D, pin 2 until pin 6 and pin 11 until pin 30. For this slide, we can see the analog input pin. Okay, there are 6 analog input pin. For particular pin, we can see throughput 20 milliampere of current for DC, and a typical 3.0 volt pin can output 50 milliampere of current, and then the clock speed can be ranging from minimum 4 megahertz, or we can say we can even start with 1 megahertz to ranging about 16 megahertz. It also has internal oscillator, so using which one of them depends upon entirely how we program the fuses of the microcontroller. Okay, for the operating voltage, the 8 mega 3 to 8P is operates between 1.8 until 5.5 volts, and it can be powered up by using DC or AC supply. Okay, that's all from me, and I will pass to the next presenter.
Okay, next the application in real world. Application in real world in microcontroller are employed in automatically managed inventions and appliances like power tools, implantable medical device, automobile engine control system, office machines, remote control appliance, and many more embedded systems. For example, Arduino, display units, coffee machine, vending machine, and the industrial water pump system.